Hey, this is a continuation of Geometry Lesson 4-2, and we are on page 225. I just introduced you to the exterior angle theorem in the last video, and that, remember, said that an exterior angle is equal to the sum of its two remote interior angles. So now let's do some math. Let's do some solving. I'm trying to adjust this. I'm sorry about the reflection on there. I hope y'all do okay with that. All right, so let's look at the top diagram. We want to find the measure of angle J right here. But we've got to use our puzzle pieces before we can do that. We can't do that until we know what x equals, and we don't know what x equals until we set up an equation. So remember, exterior angle, which we're given, is equal to the sum of its two remote interior angles that cannot be its adjacent angle, but the two on the other side or far away. So we're just going to do simple algebra here. We've got to say angle H plus angle J equals this exterior angle. So here's how we're going to set it up. 6x minus 1 plus 5x plus 17, and I just realized that this might be going out of the screen. Not quite. Equals 126. Now let's talk about why I did that. Here's my 126. Here are my two angles that I add up that are going to equal that. So now let's simplify. We've got 6x plus 5x is 11x. We've got negative 1 plus 17 is 16 equals 126. 11x is going to equal 10. And why is this not going to come out as a whole number? Hold on, let me see what I did wrong. Bear with me just 1 second. 5x plus 17 plus 6x minus 1, I just wrote that in the other order. And I should have 11x plus 16, and then I should have 11x equals, oh, that is what I have. Okay, I'm sorry. And then 110 divided by 11 is 10. There we go. So there's our whole number answer that I was expecting for that problem. All right, so now we have our x. All we have to do is put it back in. The important thing here was using your exterior angles, your exterior angle sum theorem. That's not what it's called. What's it called? Exterior angle theorem. I just put too many words in. So we said this equals this plus this. We solved for x. Now we plug it back in because remember, you have to be so careful. Did they ask you for x or did they ask you for the angle measure? That's so tricky on the tests, so be careful. Here they asked for the angle measure of J. So let's plug it back in. 5 times 10 is 50. Plus 17 is 67 degrees. So that's the final answer to that problem. Now, before we move on to the next problem, I'm going to erase this, so you pause the video if you need to go through it again. All right, here's one more dealing with the same thing. Here's our exterior angle theorem. We have the exterior angle is going to be equal to the sum of its two remote interior angles. What do we know about angle B? There's no number written there. Well, it's a right triangle, and they show us that that is the right angle. So, of course, that is 90. So here, we're going to add up angle A plus angle B. So we have 2z plus 1 plus the 90-degree angle is going to equal what? It's going to equal that exterior angle, 6z minus 9. And then we do our algebra to solve. So we're going to have 4z. And over here we have 91, we still have minus 9, so let me make sure I did all that right. That's 4z and 91 and negative 9. So now we're going to get our 4z alone. Let's move our 9 to the other side. That is 100. Let's divide 100 by 4, and that is 25, and there is our z. Let's look and see what they asked us for in this problem. They said find the measure of angle ACD. Right here. No, hold on. Find the measure of angle ACD. So we're finding the exterior angle measure this time. So we're going to plug 25 into that. So that's 25, 50, 75, 100, 25, 50. So we're at 150 minus 9. This is going to be 141 degrees. And there's our answer. All right? Okay. Let's flip to the next page. I think we just have one quick thing left to do. This is a new theorem called the third angles theorem. This one's easy. Let me get a word for that. The third angles theorem says that if you have two triangles, and these two triangles do not have to be oriented the same way. One could be upside down, or it could be a sideways orientation. It could be any way. But when you have two triangles, and each of them has two sets of angles that are congruent to each other, so look at this. We have these two triangles. We have the top angles congruent. It shows us that in the diagram. We have the bottom left, I'm going to adjust this a little bit. The bottom left angle is congruent. It shows us that in the diagram as well. What this theorem says is if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are congruent. Why is that? How do we know that that's true? Well, let's think about this. This one has to add up to a total of 180 degrees. This one has to add up to a total of 180 degrees. Let's say this is an 80-degree angle, and this is, of course, 80-degree angle because they're congruent. Let's say this is a 40-degree angle. Of course, this then also has to be 40 because they're congruent. So far in this triangle, we've used 120 degrees. The only amount that's left that can possibly be this angle is 60 degrees. Now, let me double check my math. Yes. So that means that this one, the math is the same. So this angle also can only be 60 degrees. That's why the third angles theorem exists, is so that you don't have to think through all of that math every time. It's just saying if you know that two angles in one triangle are congruent to two angles in another triangle, then you know that the third angles are also congruent. So if you knew this, you wouldn't have to do the math on this one. You would just automatically know what it was. All right, so let's apply it, and then we will be done. Let's see. There goes my marker. We are looking at example 4. Let me draw this really quickly. ABC. Sorry, I know this is making these videos a little long because of you having to wait for the diagramming. A, I think B was a right angle. C is y squared. That's its measure. Okay, now let's look, and here's an example of one that's not oriented the same way. Like I said a while ago, you need to be careful in how you compare them. And my drawing was terrible. They didn't even come out looking remotely congruent. But I'm not going to take time to fix that. Because we don't judge our geometry on appearance, right? We judge it on the facts. Okay, so let's look at this. The third angles theorem says that if two angles in this triangle are congruent to two angles in this triangle, then the third angles must be congruent. How are we going to set that up? Because they want us to find the measure of angle C and the measure of angle F right here. How are we going to do that? If this is equal to that, let's simply set them equal in an equation. Y squared equals 3y squared minus 72. Let's do the math on this, these like terms. To that, hold on just a second. Y squared equals 3y squared minus 72. So what we're going to do is I'm going to move this y squared to that side. I'm going to subtract it from both sides. That's 2y squared. I'm going to add 72 to both sides and I have a positive 72. Now I need to start getting y alone. Let's divide both sides by 2. That's 36 equals y squared. Now I need to take the square root of both of these. And y is going to equal plus or minus 6, but of course we can't have a negative length on a side of a triangle, so it's simply 6. Y equals 6. Now we need to plug that in because they said to actually find the measures. So the measure of angle C is y squared or 6 squared, which is 36. And then we would do the same thing right here. We would say 6 times 6 is 36 times 3 minus 72, which I'm not going to take the time to do because I'm going to do one more example of this with you. And then we will be done. So give me just 1 second to redraw the next one. I hope y'all are figuring out that you could be fast forwarding a little bit while I'm drawing. So we've got that one. That is NMP. This one, which is R. These are probably, once again, not at all going to look congruent, but that's okay. 32. Think about what we have to apply here. We are practicing what are we practicing? The third angles theorem. We are practicing the third angles theorem. So if we have two angles in this triangle that are congruent to two angles in this triangle, notice that they're not oriented the same way, then our third angles are automatically congruent. So now, how are we going to set that up to solve for what those angles are? We got to solve for x. We know that they're congruent, so let's simply say 2x squared equals 4x squared minus 32. Let's move the 2x to this side, so we've got 2x squared. Let's add 32 to both sides. Now let's divide both sides by 2. We've got x squared equals 16. Take the square root of both, and we have x equals plus or minus 4, but only a positive 4 would work here because it's the length of a side. All right, so we know what x equals, but they asked us to find the measures of the angles. So for example, P would be 2x squared. X squared is 4 times 4 is 16, times 2 is 32 degrees. We should find the same to be true right here. Let's try it. We have 4 times 4 is 16. 16 times 4, thinking that's 64. Yeah, so we have 64 minus 32 is going to equal 32 degrees. And there you go, they are in fact congruent, and that proves our theorem. And that's it. I hope that helps. Because there was a lot of videoage for you to watch, I will try to be selective on which problems I give you. Hope y'all have a great day.